The video for Learning Target 5.7 is going to be split up into 2 videos. So for the first video, we're going to cover this first page of the notes, which is solving right triangles. So when we say solve a right triangle, that means find all the missing information, whether that's missing angles or missing side lengths. So these 3 trig functions are the same that we have mentioned before. You can use the SOHCAHTOA to help you remember. And then, of course, the cosecant, secant, and cotangent are the reciprocals of sine, cosine, and tangent. And cotangent is adjacent over opposite. So we're going to be setting up these trig functions where there's 3 pieces of information. There's an angle theta, then you have to have one side and another side. So you're always comparing an angle with 2 sides, whether that's opposite and adjacent and you're using tangent, or adjacent and hypotenuse and you want to use cosine, or opposite and hypotenuse, in which case you have to use sine. So for this first problem, we've got a triangle that's actually a pretty poorly drawn triangle, which is going to be the case where the triangles aren't necessarily drawn to scale. So this is not a 25-degree angle. If it was, our triangle would probably look something a little bit more like that, where that'd be 25 degrees. And so sometimes drawing a better drawing is actually helps out a lot, because it lets you see if those answers that you get seem reasonable or not, or if they're maybe too long or too short. The other thing I want to point out about these drawings is that the way that they're labeled. One thing is that the point C is going to represent the right angle in that right triangle. And then you've got your capital letters A and B, and notice that the lowercase letter A is opposite angle A. So this we could label as lowercase b, and then C is always going to be the hypotenuse, because it's always going to be across from that right angle. Okay, so in this problem, when it says solve the right triangle, we need to solve for those missing things. We are missing side A, and we're missing side C, so those are lowercase letters for sides, but we're also missing capital letter B, or angle B. I'm going to start with that one because I think it's the easiest place to start. We already know a 90-degree angle, and we've already got 25 degrees. So we can add up 90 and 25 and subtract from 180, and we solve that B is a 65-degree angle. Okay. The other shortcut that you might already know is that when one angle is already 90 degrees, then these 2 have to be complementary, or they have to add up to 90 degrees. So you could also do 90 and subtract 25. For solving lengths A and C, because it's a right triangle, you might be thinking Pythagorean theorem. A squared plus b squared equals c squared, which will work if you have 2 of the sides, but it doesn't work when you only know 1 of the sides. So we have to use trig. In order to decide which one of these functions we're going to set up, we have to decide, do we have opposite and hypotenuse, do we have adjacent and hypotenuse, or do we have opposite and adjacent? So it helps to label the sides, and before you can label the sides, you have to pick an angle. Okay, because if I choose angle A, that means that side A is going to be the opposite. If I were to have picked angle B, then side B, this 32, would be the opposite. But right now I can label A as opposite, 32 as adjacent, and it doesn't matter how you pick the angles, but C is always going to be the hypotenuse. So, like I said, when we're setting up these trig functions, there's always 3 things that we have. We've got an angle and then 2 sides. So I've got my angle. I'm using angle A. Now I have to pick my 2 sides. I can't solve for A and C at the same time, but if I do want to solve for A, then I have to use the adjacent side of 32. So if I use the opposite and adjacent, that tells me to use tangent. So I would set up my equation that says tangent of theta, but I already know my angle, or my theta, is 25 degrees, has to equal the opposite side A over the adjacent side, which is 32. And now I've got my equation. I want to solve for A, which means I have to undo dividing by 32, so I can multiply by 32. So I multiply this side by 32, and if you type that into the calculator, 32 times the tangent of 25, you should get A is approximately 14.92. So we can go back and say A is about 14.92, and we can check to see if that seems reasonable with our drawing. Okay, based on this drawing, it doesn't make a lot of sense, because A and B look about the same. But if we look at this better drawing with that smaller angle, that 14.92 compared to this 32, seems very reasonable. Okay, now we've got one last thing to solve for. We have to figure out how big is angle C, or sorry, side C. What's the hypotenuse? We have two options now. Because it is a right triangle, we can use the Pythagorean theorem. And so you could do A squared plus B squared equals C squared, and you can solve it that way. Because the trig stuff is what we're working on, I'm going to set up a trig equation using the hypotenuse and my adjacent. And hypotenuse and adjacent tell me to use cosine. So I would go down here and say, well, the cosine of my angle, which is my 25-degree angle, has to equal adjacent over hypotenuse, which is C. So adjacent on top, hypotenuse on bottom. And now we can't just multiply by 32 to get rid of it because it's in the numerator and our variable is actually in the denominator, but this is a great case where we can put the cosine of 25 over 1 and then do cross multiply and divide. So we can cross multiply 32 times 1, which is really just 32, and then divide it by the cosine of 25. So C equals 32 divided by the cosine of 25. And if you plug that in, I believe that C is about 35.31 centimeters. Or units, I guess. It didn't specifically tell us it was centimeters, but 35.31. I would also check that in the drawing. Seems reasonable. The hypotenuse should be the longest side, and it is. Okay. The next one presents a little bit different scenario. Because we already have two of the sides, we want to try to solve for the missing side A, and then also we're missing the two angles. So we need to solve for lowercase a, the side length, but we also need capital A, the angle, and capital B, the angle. If we start off solving, let's say we want to start off solving for the angles. Once I know angle A, I can solve for angle B, and vice versa. If I can figure out B, then I can figure out A. So let's say we choose one of those angles to solve for. It doesn't matter. Let's say we choose this angle A up in this corner. Now I want to label the sides. So this becomes the opposite. This is my adjacent side, and this is still my hypotenuse no matter which one of those two angles I chose. So if I'm trying to solve for angle A, that's my unknown. That means that I have to use the two sides that I do know. I have to use the adjacent and the hypotenuse, which tells me to use cosine. So I've got cosine of my angle, which is A, has to equal my adjacent over my hypotenuse. And now we have to solve for A, but we can't cross multiply and divide, but we have to get rid of cosine. We want to get A all by itself, so we have to get rid of cosine. It's not multiplication, it's not division, it's not added or subtracted. So we have to get rid of it by doing the inverse, which is actually called inverse cosine, and it looks like cosine to the -1. And now that gets rid of cosine on that side. So now we're left with A. But whatever you do to one side, you have to do to the other. So we have to do the inverse cosine of that. So A equals the inverse cosine of 5/9. And you can type that into your calculator by pressing second cosine of 5/9. And it should give you the answer of about 56.25. Degrees. So we can say A is about 56.25 degrees. That opens it up to, first we can label it. Now solving for B is pretty simple because we can do 90 and subtract 56.25. which will get 33.75 degrees. You can check, all three add up to 90 degrees. And now we have to solve for A. So we've got a couple of options. Now we know everything else. You can do the Pythagorean theorem. A squared plus 5 squared equals 9 squared. You can use trig because now we know both of those. Since I didn't show you the Pythagorean theorem on the other problem, I'm going to do that here for this one. So Pythagorean theorem again says a squared plus b squared equals c squared. So I'm going to plug in those numbers that I know. I don't know a squared, but I do know that b is 5, and I do know that c is 9. So we've got a squared plus 25 equals 81. So we can subtract 25 from both sides. A squared equals 56, which means that we have to take the square root of both sides, and A equals the square root of 56, or approximately 7.48. So that's the type of thing where if I say, leave your answers exact, your answer would be exactly square root of 56. If I say round to 2 decimal places, you could say it's 7.48. And we will do the last example on the next page in the next video.